In section 6.3, we'll look at factoring polynomials of the form ax squared plus bx plus c, where the leading coefficient here, a, is not equal to 1. And so we'll use the same technique in section 6.3, but we're going to use the AC technique, which means we'll take the first coefficient and multiply by the last. 5 times 3 gives me a 15, and in the middle we'll use 16. You only use the AC method if there's a leading coefficient that is not a 1. What two numbers multiplies to get 15 but adds up to get 16? Well, that's 1 and 15. Now you don't write it as x plus 1 and x plus 15. Do not do that. That's wrong. That only works if the leading coefficient is a 1. Since the leading coefficient is not a 1, instead we have to split the middle. So we're going to split the middle, and we'll actually rewrite it as 5x squared, that's just copied, brought that down, plus 1x plus 15x plus 3. The 1x and the 15x comes from these numbers. And if you look carefully, 1x plus 15x gives us 16x. So this line and this line is exactly the same. We didn't change anything. All we changed was we made it into 4 terms. Why did we make it into 4 terms? Well, the only way to do 4 terms is by grouping, and that's the whole idea. If you look at the first 2 terms, they have a common factor of x. We'll factor out the x, leaving us 5x plus 1. For the second 2, they have a common factor of 3. That again leaves us with 5x plus 1. Since 5x plus 1 appears twice, I know I did this problem right, and so we can factor out 5x plus 1 to the front, leaving us with x plus 3 left over. And this is our factored form. We have a leading coefficient again, and so we're going to jump straight to the AC method. We're going to take the 6 and the 10 and multiply together. That's the number that goes on the top. The number on the bottom is a negative 19. Again, we use the AC method because there's a leading coefficient that is not a 1. And so what two numbers multiplies to get 60 but add up to get negative 19? The two numbers are negative 15 and negative 4. We can now rewrite the middle by splitting it into 2, so we could use factor by grouping. This becomes 6x squared minus 15x minus 4x plus 10. If I were to check, negative 15x minus 4x gives us the 19x back, so we are doing it the right way. Factor by grouping now. 6x squared and negative 15x have a 3x in common. Let's take out the 3x, leaving us with a 2x minus 5. For the second one, I have to be careful because whatever I factor out, I better get 2x minus 5 left over. In this case, I'm going to choose to factor out negative 2. That would leave me with a positive 2x minus 5. Again, I had to be careful because I wanted to have 2x minus 5 as the remaining factor here. And if you were to distribute, you do get the original polynomial back. And if 2x minus 5 appears twice, that's great. I can take that out to the front, leaving me with 3x minus 2 left over. This one's going to be a difficult problem because of the large numbers, but we can try it. There's no big deal here. 10 times 21, or negative 21, is negative 210. And on the bottom we have 29. So this one might be a little bit more difficult to find the numbers, but we could always make a list. 1 times 210 doesn't work. 2 times 105 doesn't work. We have 3 times 70 gives us 210, and that doesn't work. So we'll keep going until we do find the numbers. 210 is not divisible by 4. So we can try 5 now. I know 5 times 42 gives me 210. That doesn't quite work, so we'll just keep going. 6 times 35 gives us 210. So these two numbers do work, 6 and 35. Which one has to be negative? Well, it's got to be the negative 6, so that does work. Again, we'll just copy down the first term and then split the middle as negative 6x and positive 35x. You only split the middle if there's a leading coefficient besides a 1. That's why we have to use the AC method. For the first two, we have a common factor of 2x. That leaves me with a 5x minus 3. For the second one, we have a common factor of 7. And that leaves me with a 5x minus 3. So we know we factored it correctly because these two are identical. And so we can bring that to the front. And that leaves me with a 2x and a 7. So 2x plus 7 is our second term. Let's try this one together. Again, this is the AC method because we have a leading coefficient that is not a 1. 12 times negative 12, that's negative 144. On the bottom is negative 7. So we need two numbers that multiply to get negative 44, but add up to get a negative 7. Again, I can make a list. 1 times 144 doesn't work. 2 times 72 doesn't work. We'll keep going. 3 times 48 doesn't work. 4 times 36 doesn't work. 6 times 24 doesn't work. 8 times 18 doesn't work. 9 times 16, that one does work. We have a 9 here and a 16 here. So which one has to be negative? Well, it's the negative 16. Again, we'll have to split the middle. This gives us a plus 9x and a negative 16x minus 12. And so I can factor by grouping now. The first two terms have a 3x in common, leaving me with a 4x plus 3. The second one has a negative 4 in common, leaving 4x plus 3. Again, I chose to take out a negative 4 so that we get the same factor here, which is the only way we can finish the problem. We can factor out the 4x plus 3 to the front, leaving us with a 3x minus 4.